Okay, this is a continuation on the previous Sig Figs tutorial, so we'll call this one Sig Figs Part 2. And this has to do with actually performing calculations with numbers, multiplication, division, addition, and subtraction. In the previous video, we learned how to decide how many significant figures a number actually has. And this time, we're going to actually do some calculations with those numbers, and now we'll have to decide how many sig figs the answer of those calculations is allowed to have. So we'll go with the multiplication division rule first. The rule is that the answer of a multiplication division problem can only contain the same number of sig figs as the number with the fewest sig figs in the problem. So what that means is, down here in our example problem, we have one number, 4,853. How many sig figs does that number have? Let's do a quick review, apply the rule that we learned last time. There is no decimal in that number, so we'll start on the right hand side, find the first non-zero digit, which would be 3, count that, and everything after that moving from right to left. So that one has 4 sig figs. Now let's check 19. How many sig figs does 19 have? Good, 2 sig figs. Alright, what that means is that since 19 has 2 sig figs and 4,853 has 4 sig figs, our answer is only allowed to have 2 significant digits because that's the number with the smallest amount of sig figs. So if you do your multiplication there, you're going to come up with 92,207 as your answer. Okay, let's see how many sig figs this has. Alright, right now it's got 5 sig figs, and we have to cut it off at 2. So 2 here, 9's the first one and 2 is the second one, and we really need to drop these. Okay, so if we rewrite this, then we can get 92,000. Alright, that is our answer with only 2 significant digits. Remember, these 3 zeros here no longer count, and so we have 2 significant digits there. I also want to point out that when we drop these numbers here, that we have to do some rounding, okay? This answer here is actually just approximate, it's rounded. You have to look one more place value over and see if that does anything to your last significant digit. So 2 does not round up, alright? It just leaves it the same. That's why this is 92,000. If this had been a 5 or higher, then we would have had to round this to here to a 3, and we would have gotten 93,000 as our answer. Okay, so now the addition-subtraction rule. This rule says that the answer can only have the same number of place values as the number with the smallest place value. So if we look in our example, we have 123.47 plus 52. Okay, so looking at both numbers, let's do the 123 number first. That number has a decimal in it, so you'll start on the left-hand side, find the first non-zero digit, count that digit, and every digit that comes after it. So this one has place value out to the hundredths place. Okay. This one over here has 2 sig figs, and it stops in the ones place. Okay, so 52 is the number that has the smallest amount of place values. That means that our answer can only go out to the ones place. Okay, if you try and put more decimals in your answer, you're telling me that you're capable of being more accurate than you actually are. We're only capable of being accurate to the ones place in this problem, and if you put out to even the tenths place or the hundredths place in your answer, you're telling me you're capable of being more accurate than you actually are. Okay, so if we do the addition on that, you get 175.47 as your answer. Now again, you can't have the tenths or the hundredths place. So we need to cut it off at the ones place. Alright, you're going to look one place value further and see if that does anything to your last significant digit, and the 4 will not round the 5 up. So our final answer then is 175. So the last rule is combination. This is where you combine multiplication and division and addition and subtraction all wrapped up into one problem. The rule is that you work each part of the problem separately and you obey the previous rules. There are two parts to this problem. We have a multiplication division piece, or we have a multiplication piece over here, and we have a division piece over here. So we'll work each part of this problem individually. We'll do the 13.4 times 12, and we'll obey the multiplication division Sig Fig rule. And that one's based off of the number of Sig Figs. So 13.4 has how many Sig Figs? There's a decimal, so we start on the left-hand side, find the first non-zero digit, count it, and everything after it. So there are 3 Sig Figs on that one. 12 has no decimal. Start on the right-hand side, find the first non-zero digit, count it, and everything after it. So this one has 2. So this is the smaller one, so our answer can only have 2 significant digits. When we do the multiplication, you get 160.8. Okay, so there are our first 2 Sig Figs, and that's where we have to cut it off. That doesn't mean the answer is 16. 16 is not equal to 160.8. Okay, so the only way that we can do this is by changing this into scientific notation. And if you need a review on that, you can reference that video, and I'll try and put a link in this one to that video. So you move the decimal behind the first non-zero digit and rewrite your number. Then you add times 10, and we have to decide what the exponent's going to be. And the exponent is the number of times that you moved the decimal place. So in this case it's 2. Then you have to decide if that exponent is going to be positive or negative. If the original number is greater than 1, then the exponent is positive. If the original number is less than 1, then the exponent is negative. So in this case, 160.8 is greater than 1, so our exponent is going to be a positive 2. Now, by looking at this, you can see we have 4 Sig Figs, not 2. So we're going to cut it off here at our second significant digit. You have to look one place value further and see if that is going to do any rounding. It will not. So our final answer for this piece is going to be 1.6 times 10 to the second. Okay, now let's come over here and do this division part of it. 19.7 has 3 Sig Figs, while 2.1 only has 2 Sig Figs. So again, we're going to have to cut our answer off at 2 significant digits. When you do this division, you get 9.380952338. Okay, well that's obviously a lot of Sig Figs, and we need to cut it off at 2, which is going to be at the number 3. You'll check one place value further and see if it does anything, and in this case it actually does. You're going to get 9.4 for this piece of the problem. So we'll just drop that down here. And now we're ready to do the addition piece of the puzzle. Okay? So we're going to have to obey the addition subtraction rule here. We just got done obeying the multiplication division for both parts of it. Now we'll do the addition subtraction part. So that one was the one with the fewest number of place values. So for this problem, you'll notice that both of these go out to the 10ths place, which means it is perfectly fine for our answer to go out to the 10ths place. So if you add 1.6 times 10 to the second plus 9.4, you get 169. You get 169.4. as your answer, and that goes out to the 10th place like it's supposed to. So that's our final answer, 169.4. Okay, that completes our section on significant figures. You now know all the rules, so we'll be using those rules throughout the rest of the course. Thank you for learning with me. I'll see you next time.